Hello everyone, welcome to the Connect series. If you haven't tuned in before, this is a series of videos where we dive into different forms of connectivity and the technology that TI is bringing to market to enable developers to connect their various applications. And along those lines, we wanted to start expanding beyond the SimpleLink portfolio, which we've talked about, ad nauseum in the past. We want to start pulling other connectivity devices from the broader TI portfolio. And in order to do that, we're bringing in Vihang Parmar from our Wi-Fi marketing team to talk a little bit about Wi-Fi technology that we're integrating into the grid space. So without further ado, let's jump right in. Let's learn a little bit more about Wi-Fi connectivity inside of the grid space. So Vihang, thank you so much for hanging out with us here today.
Hey, thanks Adrian, thanks for having me today.
Yeah, absolutely. This is a topic that I personally don't know a ton about. So really interested to learn more, get the lay of the land, and kind of understand where TI is innovating to enable Wi-Fi connectivity in the grid space. And I know, when we say grid infrastructure, it's a pretty broad term. Do you mind giving a quick 30,000-foot view as to what that encompasses?
Yeah, sure thing. So the grid infrastructure, the way we see it, it includes all the different various end applications where you have either a smart meter that is connected to sensors over wireless network or connected to internet over Wi-Fi, from those metering applications where you need Wi-Fi for diagnostic and or remote control. From there to also some of the emerging use cases like EV charging stations for both residential and commercial settings, as well as some solar inverters where the use cases would be similar. You see solar inverters these days using Wi-Fi networks to connect to your home network or the building's wireless infrastructure. And you can see all the critical electricity consumption and the overall loading information through that. And at the same time, if you need to diagnose the device, it also allows you a remote port to diagnose the device.
Gotcha. Okay, very cool. Yeah, and we've had other guests, talk about connectivity in the grid space, but that has typically been more kind of edge node related, looking at some of our sub-1 gigahertz technology for really long range, low power transmission. So Wi-Fi obviously is a different animal. At what point would I decide that Wi-Fi is a better technology for me? For my particular grid application, are there particular careabouts that would make Wi-Fi a better fit for me as a developer?
Yep, exactly. And I would slightly change that question in a sense that I would not say that a developer should think that whether I need a sub-1 gigahertz radio or Wi-Fi. The role of Wi-Fi is to add to the functionality of the grid equipment that already have sub-1 network or Zigbee capabilities and so on. So the way I would present it would be that Wi-Fi allows you to add a remote control, debug, and diagnostic port for your grid applications, whether that's a electricity meter, a solar inverter, or in case of electric vehicle charging. It has some additional benefits where you can add Wi-Fi to an EV charging station. For residential, of course, you can remotely monitor how your car is charging and also control what time to charge and so on. And for commercial settings, you can also use that Wi-Fi as a kind of an added benefit for the passengers in the vehicle to provide them a Wi-Fi connectivity while they're kind of charging their EV for 10, 20, however long it takes, however many minutes it takes. So those are some of the kind of new features that Wi-Fi allows you to add to your grid applications.
Oh, perfect. Okay, that makes a lot of sense. So in many cases, you might have multiple forms of connectivity within your grid infrastructure, and I guess Wi-Fi in particular is really enabling that cloud link, and that allows things like remote monitoring, diagnostics, so on and so forth. That makes a lot of sense.
Exactly, and I would actually add to that we see several different flavors of Wi-Fi being used in grid applications, right? One of the most common one is a 2.4 gigahertz Wi-Fi radio that can, of course, connect to your home or commercial wireless infrastructure. And because it's 2.4 gigahertz only, you can expect long-range connection and a reliable connection over long range. So that's something that TI, especially in our WiLink product line, we take pride in that we have one of the most reliable and secure solution for these applications.
Okay, very cool. So you mentioned the WiLink portfolio within TI, I guess being a good fit for these use cases. Can you dive deeper into some of the IP or innovation that's integrated into that device? You touched on security. I don't know if there's any other key technology there that might spike the interest of developers out there looking at adding Wi-Fi to their infrastructure.
Absolutely. So a couple of technology that I would mention would be for smart metering and for solar inverter type of application. It's really the long-range operation and a reliable connection. So in our WiLink family of devices, we have several variants that use either single antenna or dual antenna solutions. So what dual antenna allows you to do is to use something called a MIMO. It's a multi-input, multi-output type of setup where you can increase your overall throughput of the network. And also in 2.4 gigahertz band, you can use dual band antenna or a dual antenna setup to use a feature in our WiLink devices called MRC, maximal ratio combining. So that allows you to combine receive signal from two different antenna, and the radio adds it up and uses the sum of the two. So that allows you somewhat of an extended range, almost 40% improvement in the range by having two antennas. So those are some of the features that we're leveraging on the use cases like smart meters, solar inverters, and on the EV charging side. Like I mentioned, one of the added benefit of having Wi-Fi for commercial settings is to provide a cloud connectivity to several chargers that will be in close proximity. And one of the features we have there is our Wi-Fi mesh technology that we have in WiLink products, where you can have up to 10 chargers all connected to the same mesh network. And then you can have like an Ethernet connection or a kind of a cellular network connecting that one hub to the internet. So that allows you to save on a lot of BOM material for Ethernet or the cellular network while using a Wi-Fi network that's already present in there.
That's awesome. That's really cool. So, with that cloud connectivity, you have the ability of, I think, doing some kind of big data analytics almost, right? Looking at the load management maybe of, multiple charging stations or whatever that might be. These WiLink devices, they're very powerful. I guess you have the ability of doing some of that analytics maybe locally, at the edge, as opposed to sending everything up to the cloud. Is there, any key capability there to allow the developer to make intelligent decisions on the device as opposed to leveraging the cloud all the time?
Yeah, definitely. So these WiLink type of transceivers, they're usually paired with a powerful microprocessor that would be like a Cortex-A type of device that would be running a high-level operating system like Linux or Android and so on. So a lot of that kind of local decision-making, we have a very active community of open source community on TI Sitara processors, which are our TI MPUs. And there you see a lot of different projects popping up in the same realm where you gather data from different sensors, and how do you process that, and how do you do some of that analytics locally on the processor. WiLink allows you to easily integrate Wi-Fi and, if required, Bluetooth connectivity to those processor-based systems.
Very cool. Vihan, I'm learning a lot here. That's awesome. And you were touching on developers here a little bit. Can you talk to how developers can get started with WiLink devices in the grid space? Are there particular devices or EVMs a developer can get started with?
Yep, absolutely. So I would say one of the first things I would recommend would be to look at our WiLink WL1801 mod. That's a 2.4 gigahertz Wi-Fi transceiver solution. And we have easy integration guide and also evaluation modules where you can plug in our WiLink family of devices to a Linux processor and easily bring up the Wi-Fi functionality that's native to the Linux environment.
Awesome. So hardware and software, the developer is ready to go.
Correct. Yep.
Very cool. Vihang, thank you so much. I learned a lot here today, and hopefully the viewers at home, learned a little bit more about how Wi-Fi connectivity is augmenting the grid infrastructure space, and how TI is taking advantage of our wireline technology to make that happen. So Vihang, thank you so much for hanging out here today, and for those at home, be sure to check in next week where we'll bring in other TI experts and talk about how we're connecting different applications and end equipments with TI technology. And as always, if you have any feedback, feel free to tweet at us at Sensor to Cloud. Otherwise, we'll catch you guys next time. Thank you so much.